Okay, so that is, just a short overview of what machine learning is. Let us more concretely illustrate this with a number of, applications of machine learning, right? Just so you can see more specifically what are some of the things that we can. Some of these things you might be familiar with, some of them might not be. In any case, they're just a sample of the many things. I mean, there's more things being done with machine learning today than anybody can keep track of. So I've started with some of the ones that are more, let's say, current and commercially important, and then, gradually moved on to the ones that are more speculative. But even the more speculative ones are not that speculative these days. So, of course, a very good place to start, which I already mentioned, is web search. The single most, these things are closely guarded secrets, right? But what seems to be the case from what people like Prabhakar say is that the single most important ingredient in designing a search engine is the following. When the engine gives you a set of pages, right, and their summaries, you click on some but not others, right? You click on the one that looks most interesting to you. And if that's the one you want or it satisfies your needs, then you're done. Otherwise, you might go back and click on others or even refine the query, right? Now, if you think of this as an input for a machine learning algorithm, this is a beautiful thing to have, right? Because what this input-output pair is saying is, if I put up these web pages for you, then you'll click on these ones. So what the machine learning algorithm can learn to do is predict which pages you will click on. And then it actually just puts those up. It puts up the ones that you are most likely to click on instead of, letting you see all the dreck. And the other thing is that, search engines have a lot of data, right? They get billions of queries every day. You'll get a lot of data to do this. So at the end of the day, by using machine learning, you wind up with a much better search engine than you had in the days when machine learning wasn't used for search. Here's another very different example. Computational biology. Very big area for machine learning. There are many different applications of machine learning in computational biology, but think of just this one. Drug design. In the old days, companies designed drugs by trying things out in the lab, right? Slow, painful process. And it was very trial and error, very random. And for a while this worked. But these days they have largely run out of what they can do with that. So now we know what they do is what's called rational drug design. One of the big components in rational drug design is like you try to design the drugs and be fairly sure that they're going to work before you actually try them in the lab. For the cost and time of trying one drug in the lab, you can try millions of them on the computer. And this is where the machine learning comes in. Right? I know something about molecular biology. I have examples of molecules and what they do. Like, for example, how they dock to viruses and inhibit them and whatnot. And now what I can do is I can try to predict for other molecules by generalizing from, again, the ones that I saw, how these ones are going to behave. The input is the molecule, and the output is it going to do what I want, or, how will it dock and whatnot. Okay? So this is one very important application in computational biology, but there's many others. Here's another great one, finance. Finance was actually one of the early major applications of machine learning, even before the web was around, and everything on the web uses machine learning these days. Think of a bank, right? One of the things that banks do is they send you credit card offers, right? They use machine learning to decide who to send what offers to. They have data on you, and from that data, they try to figure out, using a machine learning program, how to predict whether, you are a good credit risk or not. And if you're a good credit risk, then they will send that to you. If you just go to the bank as a company or an individual and make a loan application, chances are your application will be evaluated by a machine learning program. They do not use that much, at least for loans of a certain scope, human evaluators anymore. They use machine learning programs. Again, they have a big database, right, of their previous loan applications and whether the outcome was default or whether they paid on time and whatnot. So you can use machine learning for that. And then they have all this money from you. They need to decide how to invest it, right? Machine learning comes in again. You can use machine learning to try to predict stock market, currency fluctuations, whether companies are going to, make money, et cetera, et cetera. So machine learning gets used very extensively for this type of thing. Next thing, they're worried about whether they're going to lose you or not. So they can use machine learning to predict whether you are likely to leave or not, to drop them for another bank or another credit card and make an offer to you at that point. They can even use it to decide whether they think you're not really worth keeping and subtly try to discourage you, right? I'm not going to say whether they do this or not, but they might. Finally, they're also worried about fraud, right? There's a lot of fraud with credit cards and whatnot, and machine learning is a huge weapon in fighting fraud. Actually, not just in finance, but in everything. Because again, what you do is you figure out what are the signs that, credit card has been stolen, and then they suspend the credit card. You've probably had this experience, right, of, getting a call from the bank saying, or an email, your transactions are suspicious, can you confirm that these are yours, right? And there's more, but this is just a sample of the things that machine learning gets used for in finance. Okay, so to take a totally different application, space exploration. Here's 2 examples of space exploration. You send a probe out there to Mars, and the probe is on its own. Right? Light takes 10 minutes to travel between Mars and Earth. Right? So if the robot has to be instructed by people, it slows it down by orders of magnitude. So the more autonomous the robot is, the more productive it will be. Well, it needs learning algorithms to figure out what to do on its own. Another example, right? Astronomy and planetary science are one of the big producers of masses and masses of data. Like you send a probe to Venus, and it takes pictures of the entire surface. This is a real example. And now the planetary scientists want to figure out where the volcanoes are on Venus, because that allows them to test years of planet formation. Well, in the old days, you would have to pay someone to look at these plates and say, volcano, not volcano, volcano, not volcano. And of course, that only scales so far. These days, you get a machine learning program to figure out what is a volcano and what is not. It learns from a much smaller number of examples that were labeled by people, but then it goes off on its own. And in the same way, you can form, catalogs of stars and galaxies and other, objects in space and whatnot. Robotics is another example. And at this point, it should be obvious, right? Robots, right, the more autonomous and flexible they are, the better. There's actually lots of robots in industry today, but they are very inflexible. They do one movement or a few, a sequence of movements in a very well-controlled environment. They're not flexible. They can't react to failures. You want to make them more flexible without having to program this all yourself. In many cases, you don't even know how to, right? You want to program them to grasp this or that and tomorrow it's a different object. You can use machine learning for that. And more, that's what people do. As a very famous example of this, right, the famous, self-driving car, right? These days, we're at the point of having cars that will actually, be your taxi and not actually have a driver. If you talk, to the people who built these cars, they will tell you there's machine learning in every nook and cranny of what they're doing. Right? Information extraction. Right? How do we make computers smarter? Right? It's one thing to use a search engine and type in a few keywords and get back a bunch of documents, but that's not really what you'd like to have, right? What you'd like to have is the ability to ask questions, and this thing answers your questions by reasoning over databases that it collected from the web, right? This is a very big agenda for a lot of companies on the web, and definitely good for us as users. Again, the way to make that work is to use a lot of machine learning to be able to do the information extraction automatically. Here's one that used to be somewhat futuristic, but no longer: social networks. Right? 10 years ago, machine learning was already exploding, but social networks were still on nobody's radar. These days, of course, social networks are one of the biggest things on earth. You've probably heard that Facebook is about to go public, valued at something like $100 billion, right? Why are they worth $100 billion, right? And if you read the stories on this, the number one reason they're worth $100 billion is that they have this mother load of data about how people relate to each other, live their lives, do things with their friends, what they prefer, what they don't, right? Their ability to mine that data and then use it to select, for example, which banner ads to show and, and other things is what makes them so valuable, okay? So first of all, you have a company that gathers a huge amount of social information, right? The social graph and lots of other things. But then, right, the question is, what value can you extract out of that data? The better your machine learning, the more value you can extract out of it. And if Facebook is already worth $100 billion with the machine learning that they have today, imagine what it would be worth with machine learning that was much better. Okay, and it's coming. Okay, so let me give as a last example one that's completely different from all of these. Machine learning is now becoming very popular for basically for every problem in computer science and beyond, but in particular for things like systems and software problems. You can use machine learning to try and optimize the behavior of your data center, to make it faster to respond, to make it consume less power. You can use machine learning for things like debugging, right? We all know that debugging is one of the most annoying and most labor-intensive processes in software development. Wouldn't it be great if we could partly automate it? Notice it doesn't have to be the case that the program will find and fix the bug all by itself. But if the only thing that this program does is it tells you what are the 10 most likely places where the bug is, this would already be very useful, right? It will save you from looking for a needle in the haystack potentially. And again, you can use machine learning programs for this. You can use traces of the program running. You can use traces of how people debug their programs in the past. And again, try to predict from the program and from what happened there, was there a crash, was there not a crash, what did the user do, what did the programmer do, right? What did the compiler produce? From that, try to learn where the bugs are and where they aren't. Okay? And, these are just a few examples, but what I really like you to think about is what is your domain of interest. What problem are you interested in? And how would you apply machine learning there? Maybe this is a problem where machine learning has already been applied, but chances are you can come up with a different angle on it. Maybe this is a problem where machine learning has never been applied, and there's a huge opportunity for you there. Okay? And if you do decide to do that, and have questions and thoughts, please talk to us. We'll be very excited to find out what you're up to. Okay? All right. By the way, this part of the class is kind of like a cocktail party, style. The rest of the class is not going to be like this, right? It's going to be more, concrete and more problem solving. But, enjoy this part while it lasts. And also, I think it's useful to have sort of like this overview of what machine learning is and what it's good for before we dive into the details. Any questions? Thoughts so far? Okay, let's keep.